curve. And so you don't have to do a lot of calculations with this, but you do know how to interpret it. So when we're looking at the normal curve, and then there was a couple questions on Khan Academy that were there, and so I'll answer. There was a big long list of these. I'll do a couple. But first is just to understand what this means. So the mean could be any mean, right? If we have a mean height or a mean intelligence score, or up here we have the mean weight of huskies. So we're just saying whatever the mean is, that's the center of our graph. That's in a normal curve, that is the middle. And in a normal curve, the mean, median, and mode is all going to be around the same spot. And then we start looking at going away 1 standard deviation less, 2 standard deviations less, 3 standard deviations less. In the context of the problem, like up here it says the standard deviation is 7.5, the context of the problem is going to tell you this, so I can start adding some of this problem in. So this first problem, number 2, says the mean is 52.5. So that's the value here in the middle. And it says the standard deviation is 7.5. So if I take 52.5 and I subtract 7.5, it's telling me that this next value here is going to be 45, because 52.5 minus 7.5, right, minus 1 standard deviation, leaves me at 45. And then I subtract another 7.5, and that gets me to 37.5. And if I were to subtract another 7.5, I would get to 30. All right, so now I'm over here, this value is 30. That's 3 standard deviations away. And if I did it on the other side, 52.5 plus 7.5 is 60. So this means that I'm here at 60. And then if I add another 7.5, I would be at 67.5. 67.5, and if I added another 6.5, or sorry, another 7.5, another 7.5, I would be at 75. So 3 standard deviations would be 75. And I would have to do this in every situation, right? If I was looking at 3, it's telling me that the mean is 125. So again, in this situation, this is 125. And then I'm adding or subtracting the standard deviation of 75. So 125 plus 25 is 150. Right here, 2 standard deviations up would be 175, and 3 standard deviations would be 200. And if I went the other direction, right, I would have 100 and 75. And the last one, oops, the last one would be 50. All right, now because it's a normal curve, it always has these percentages. What do these percentages mean? It means that in this space between the mean and 1 standard deviation, 34% of the population is going to fall in that space. So 34% of all the, whatever it is, all the huskies, all the people, whatever the population is, 34% is going to fall between the mean and 1 standard deviation above. And it's symmetrical, so between the mean and 1 standard deviation below is also that percentage. And we can look, these are together, right? This plus this gives us this. This plus this plus this plus this gives us 95. And then if we were to look at all the data between minus 3 standard deviations to plus 3 standard deviations, that's 99.73% of all the things. Of all the, right, there's very, very little percentage in these little tails. All right. And that's like, I can tell you that the mean of IQ is 100 and the standard deviation is 15. So 115, 130, 145. Very, very, very few people, 0.014, have an IQ above 145. And we're going to look at IQ later in the year. But anyways, let's finish these questions. It says, considering a full-grown Siberian Husky has a mean weight and a standard deviation of 7.5, how common are male Huskies and the 37.5 to 45. So between 37.5 and 45, right? So how common they are? 13 point, we can even really close to about 14% have weights that are in that range. A population has a mean of 125 and a standard deviation of 25. How common are values in the 100 to 150 range? Well, we label it out 100 to 150. 68% of the population will have values between that, right? Rounding off. All right, so I hope this helps you read the normal curve. And if you have any more questions, please let me know.